So now we will try to understand about a single perceptron, and we will see how we use one line to separate out the different regions. Here we have a perceptron with certain values. We can see x1 and x2 as the input and 1 being the constant output or weight or bias that we are adding here. We have a summation symbol here which indicates that there is some level of filtering going to happen or some level of processing of data is going to happen, and then there is an activation function symbol here which is given. So these are our inputs. This is our neuron where we process the information, input information. This is basically an activation function, basically how we process the information. And here we have an output as a predicted value. So W0, if you consider, is equal to 1. And as we see, the input value as 3 and minus 2. So 3 and minus 2 are the two values. And if we want to process this information, we will pass this set of input or the matrix in a function g. And this function g, the value is going to be w0 plus xt of w. Now, this w0 plus xt of w basically helps is the value or the input value that we have received, and we when we pass on this value as into this function. So basically, if we pass 1 plus the xt or the transform of x matrix, so transform x matrix is going to be uh, x1 x2 as the values as a transformed version of x1 x2 as a matrix or a vector, and w is the weight, so weight 3 comma minus 2. So we get an equation that is 1 plus 3 into x1 minus 2 into x2 based on the values of 3 and minus 2. So this is just a line which is a two-dimensional line, and this two-dimensional line basically kind of helps us out to do some kind of prediction over a data. So a single perceptron helps us out to create this value or get this value, which is a two-dimensional line, and we apply some processing or functions over it. Now, similarly, if we process the data, if you use one line to separate out this different region, if we consider that particular line 1 plus 3x1 minus 2x2, we can see that if x value, and we are putting the x value as minus 1 and 2 over here. So 3 into minus 1 minus 2 into minus 2, if we are putting it, so this value point data point 1 minus 1 comma 2 is going to be in the upper half of this line, and it will lie and it will have g of minus 6. You can see the total value is coming out to be minus 6, and the function we are applying g. After applying this function, the value suppose is going to be 0.002. So basically this value now indicates where or in which category this point is going to lie. So single perceptron has this value. So this is how the calculation actually happens in a single perceptron. And similarly here as well, so any value, if we see if the z value is less than 0 and if y value is less than 0.5, in this cases this is going to be in this blue category, and if z value is greater than 0 and y value is also greater than 0.5, so in this case the data point will fall under this green category. So there are two categories, that is blue and green. And this is how a single perceptron builds up or divides the data. It has a simple logic. Basically, there is a function which will divide the data into two halves based on the line that we are going to create. Now we'll talk about multiple classifiers. So perceptron, which is a two-dimensional figure, can't represent XOR problem because XOR problem required two lines. So we can solve this problem with either of the two methods which are used in machine learning by adding dimension and support vector machine using polynomial kernel. We can use a polynomial kernel, or by adding layer in neural network which is used for complex operations. So we can add two layers, like two neurons basically. So in either of the case, we can use first one as the polynomial kernel using sub SVM, or the second one, as we said, that we can have two neural network layers.